Mathematicians in the building. Today, let's look at rationalization of surds. What does it mean when someone is asked to rationalize surd? We say that rationalization of surd is the process of removing the irrational parts from the denominator of a surdic expression. Removing the irrational part, that's the radical. When we say the irrational part, for example, if we have 1 over root 3, this root 3 is what we call the irrational. We say this is irrational, or which is the radical. So if you have 1 over 2 root 7, this root 7 is the what? Irrational part, or which we call the radical. So I added it as the radical. So this 2 is the coefficient of the radical. So the process of removing this root 7 is what we call rationalization of surd. Mind you, it doesn't mean you should just remove the roots and say maybe 1 over 2 times 7, or say 1 over 2, since you have removed this one. No, it doesn't work that way. So we are going to look at the procedure for rationalizing surd. We are going to take some couple of examples. First, you need to understand some of these basic rule when rationalizing surd. When you have 1 over root a, we say to remove this irrational part, this square root, you just multiply both the numerator and the denominator by this radical. So you have root a over root a. So in other words, 1 times root a is root a all over root a times root a is a. Of course, you know root a times root a is root a squared, and this cancels this, which is a. So this is the first rule. In other words, if you have 1 over b root c, just multiply, find out where the radical is, which is the root c. You don't need to bother about the coefficient. It's just attached to it, so you just multiply by root c all over root c, both the numerator and the denominator. So you have 1 times root c, you have root c all over b root c times root c, you have what? bc. Of course, root c times root c is c times b, bc. So you need to understand this is the basic rule. But if the denominator is a compound expression, then use the conjugate of that denominator. Please don't be worried about the term conjugate. It's just the opposite of the denominator. That's reversing the sign of the operation joining the compound expression. So for example, if you have 1 over a plus root b, this is an expression, a compound expression. So the conjugate of this denominator is reverse the sign of this plus to minus. If it is minus, reverse it to plus. So plus goes to minus, minus goes to plus. So the conjugate will be a minus root b. So if you want to find the conjugate of b, of 1 over a root d minus root f, the conjugate is what? A root d. That's the conjugate of the denominator is a root d minus root f, reversing the sign. That's how to get the conjugate. So when you get the conjugate, you now multiply multiply the numerator and the denominator by the conjugate. Then by so doing, you will remove the irrational part. Let's take an example for both cases. 1 over root 3. In this case, this is the same thing as saying 1 over root 3 times, remember, root 3 over root 3. And this is the same thing as root 3 over 3, because root 3 times root 3 is root 9, and the root 9 is 3. Now let's take another example. You have rationalize, let's say this is A, B, rationalize 2 over 3 root 7. In this case, you have 2 over 3 root 7. So remember, you multiply by the radical, both the numerator and the denominator. So you have 2 times root 7 is 2 root 7 over 3 root 7 times root 7 is the same thing as 3 times 7, which is 21. So this is 2 root 7 over 21. Now let's look at this case. 1 over 2 minus root 3. Now in this case, this 2 root 3 is now a compound expression. The 2 is not a coefficient, mind you. Don't confuse it with this kind of case. This kind of case is different from this. In this case, 3 is the coefficient of root 7. But in this case, there is subtraction between them, making it a compound expression. So you need to find the conjugate. And of course, you know the conjugate. The conjugate is 2 plus root 3. So you're going to multiply by the conjugate for both the numerator and the denominator. So you have this times 2 plus root 3 all over 2 plus root 3. So the same thing, multiply up and down. So now you have 1 times 2, you have 2 plus 1 times root 3. 1 times root 3 is root 3 all over 2 minus root 2 times 2 plus root 3. Remember your difference of two squares. Remember the difference of two squares. Difference of two squares. If you have a minus b times a plus b is the same thing as a squared minus b squared. The same goes with a plus b times a minus b. So you have a squared minus b squared. So based on that, you have 2 squared minus root 3 squared. And this is the same thing as 2 plus root 3 all over 4 squared. 2 squared is what? 4. Minus root 3 squared is what? 3. Because this can cancel this. So you have 2 plus root 3 over 1, which is 2 plus root 3. So you have succeeded to remove this irrational part from this denominator. This becomes a value answer. So take this example. If you want to rationalize, you have 2 plus root 3 all over 2 root 3 minus 1 times the conjugate 2 root 3 plus 1 all over 2 root 3 plus 1. So in this case, you have 2 times 2 root 3. You have 4 root 3. 2 times this one, you have 2 root 3 times 2 root 3. You have 6, because root 3 times root 3 is 3. And 3 times 2 is 6. Root 3 times 1, you have root 3. All over, remember, we have to square this and subtract the square of this. So you have 2 root 3 squared minus 1 squared. So this is the same thing as 4 root 3 plus root 3, we have 5 root 3. 2 plus 6 is what? 8. All over 2 root 3 squared. This is 2 squared is 4. 2 squared is 4 times root 3 squared is 3. So 4 times 3 is 12 minus 1 squared is 1. So you have 5 root 3 plus 8 all over 11. So what do? You need to rationalize the expression. So you have the equation. You have 2 plus root 7 divided by 5 minus 2 root 7. So we need to rationalize by multiplying both the numerator and the denominator by the conjugate of the surd of the denominator. You have 2 root 7. So when we carry out this multiplication, 2 times 5 is 10. 2 times 2 root 7 is 4 root 7. Root 7 times 5 is 5 root 7. Root 7 times 2 root 7 is 14. Because root 7 times root 7 is 7. 7 times 2 is 14. So root 7 times 2 root 7 is 14. Divided by, you have 5 squared minus 2 root 7 all squared. So you have 10 plus 14, collecting like terms, we have 24 plus 4 root 7 plus 5 root 7. This is the same thing as 9 root 7 divided by 5 squared is 25 minus 2 root 7 squared. 2 squared is 4. Then 7 root 7 squared is 7. 4 times 7 is 28. So you have 24 minus plus 9 root 7 divided by 25 minus 28 is minus 3. So this is the same thing as saying, minus 3 brackets 8 plus 3 root 7 divided by 3 minus 8 minus 3 root 7 is equal to, because this expression is the same thing as this, so we can now say minus 8 minus 3 root 7 is equal to P plus Q root 7. That is, if you now do comparing of terms, it means that P is minus 8 and Q is minus 3. So mind you also that this can be said if this is expressed in this form, where P and Q are rational numbers, find the values of P and Q. So we may not necessarily put equal to, because equal to may also mean that we need to begin to solve this equation. Just understand that the principle is they are trying to let you express this in this form so as to be able to evaluate it in this form. So whatever your answer is, you now compare the coefficients, and that solves the problem. See you next time. Remember to subscribe and to like our video. Bye-bye.